All right, guys, so thank you for coming. I think we're going to get started. So I'm Nicole Duggan. I'm one of the ultrasound faculty at Brigham Women's Hospital. We are going to be talking to you today about machine learning in the context of medical imaging with point-of-care ultrasound as kind of our case study. And so we've got a great team for you. So like I said, I introduced myself. We've got also Andrew Goldsmith, who is our division chief of ultrasound. We've got Chanel Fischetti, who manages all of our strategic collaborations with the ultrasound department. So we have a great crew for you here. Thank you for joining us today. We do have some disclosures. So Dr. Fischetti was a former CMO of Centaur Labs and also consults with Level X, and Dr. Goldsmith consults for Echo. I have no disclosures myself. All right, so today we're going to go through just a few basics on artificial intelligence and the use of medical imaging with point-of-care ultrasound specifically. So I'll walk you through just kind of a very basic intro to AI. It can be really confusing with all the terms that people throw around, and so I'll try to simplify it a little bit and walk you through it. I'll talk about AI and POCUS, and then Dr. Goldsmith will come up and give you really interesting perspective on some of the financial implications of using AI in medical imaging and point-of-care ultrasound specifically, and kind of how that reflects in our practice. And then Dr. Fischetti is going to talk to you about next steps and looking ahead for the future of what kind of implications incorporating some of these tools into our practice might mean. All right, so like I mentioned, so the terminology can get really confusing. In popular culture, things like artificial intelligence, machine learning, deep learning, they get thrown around kind of ambiguously, and it's not always very clear. So I like to kind of explain it as, think of artificial intelligence as kind of the umbrella term, kind of the all-encompassing mother term of what we're talking about today. And all it means is the art of giving machines human-like intelligence. That is literally what everybody will say when you ask them what artificial intelligence is, and I feel like that's still not clear. So I try to break it down into things like machine learning and deep learning, which are subsets underneath artificial intelligence. And they're kind of the most important subsets when you're thinking about AI for medical imaging specifically. So starting with machine learning, which is kind of the simpler of the two, it is a way to have algorithms recognize patterns in any data that you feed it. So it's usually a fairly linear kind of thought process, and it relies on mathematical algorithms to extract patterns out of any data. So it's fairly simple in terms of its processing compared to deep learning, and you have to tell the algorithm or program the algorithm what output you're looking for. So I need to say, I want you to identify XYZ out of this data. I want you to give me this output. It can't extract that information on its own. Deep learning, on the other hand, which is what is more useful for things like point-of-care ultrasound or medical imaging in general, is a lot more complex, and it solves problems in a more simultaneous sort of fashion. Instead of like a linear thought processing or a linear calculation, it has multiple layers that can all interact with each other and talk to each other to solve whatever problem you want. You don't necessarily have to tell a deep learning algorithm what question you're asking. You can give it a group of data, and it can extract patterns out of that and kind of give you outputs based on the data that it sees. And so it's not necessarily something that you have to program in explicitly. Because of the differences in the complexities of the models, machine learning is usually a bit faster to run. It's moderately accurate and kind of moderately robust, and you don't need as much processing power for it, which is why it was kind of used earlier. It was an easier thing to start working with when we had limited processing power. And I like to use the example of like auto EKG interpretation. So think of those. Those are like some of the simplest examples of machine learning, and some of the really simple ones are even like a pre-machine learning step. But those are, kind of accurate. They're like not great, right? And we all see them on the top of our EKGs, but it's fast enough that it can be spit out as EKGs are coming. So it processes quickly, but the accuracy is questionable, right? Whereas deep learning, on the other hand, it's a more robust means of solving problems, which makes it a lot slower. So you need lots of processing power, you need a lot of time, and you need a lot of data to really make these models pretty robust. And so data scientists kind of built these models, these deep learning models, off of our own brains, right? So our own neural networks. And so the type of way that these deep learning networks are organized is into things that we call neural networks, and in the case of medical imaging or point-of-care ultrasound, we use convolutional neural networks. So this helps me kind of conceptualize. You can think of a brain with all the neurons kind of interconnected and everything talking to each other, both backwards and forwards. That's sort of what we're talking about when we talk about deep learning. If you want to take a closer look at how a CNN works or a convolutional neural network works, so you have your input data, right? So an ultrasound image, for example, you can do a still what have you. The model is gonna do a feature extraction step first. So it breaks this image down into tiny, tiny components. It'll look at every little layer of the image, break it down into different structures that it recognizes, different colors, different compositions, different contrasts of the image, and it'll layer those all together and put it into the actual model step itself. And so if we're talking about a classification model, for example, it'll look at all of the patterns that it recognizes, see which patterns fit together, and see how that relates to data it's seen in the past, and it'll spit out an output. And so generally what these outputs are, they're probabilities. They're not necessarily 100% yes-no answers, they're probabilities. And so based on how good the training data was, how good the model was programmed, how much data it's seen in the past, the probabilities could be more or less accurate, right? And so in theory, the more data you feed it, the more accurate it gets. And so, for example, this output would be, 70% this is a lymph node, 20% this is an abscess, 20% is a vessel. Depending on how accurate your model is, you could, with some level of confidence, say that's probably a lymph node. So that's kind of the basics of how these CNN work. And then the types of questions that we like to ask with these models, specifically when it relates to POCUS, are things like classification, which is a yes-no answer. So are there B-lines present in this clip or not? The prediction is usually a binary of some kind. So B-lines or not, abscess or not, things like this. Those are the most helpful classification tools. They're a bit easier to program. They're a little bit easier to train. But segmentation, which gives you kind of a spectrum of answers, so it can localize, for example. So you see the clip on your screen right, which is localizing the B-lines instead of just saying yes or no, there are B-lines present. And so that will give you a score based on the probability of what it actually is asking. So, for example, the red here is much more confident, and the blue, I guess, would be less confident, and so they're all probabilities. And so segmentation is a little bit more complex. It answers more interesting questions, I think, but it is also harder to train and harder to program. So that was kind of a quick overview of the CNNs and the deep learning models that we use and we think about when we use point-of-care ultrasound. Are there questions on that part? I'm going to pull it back to point-of-care ultrasound pretty quickly. No? Okay. So in terms of point-of-care ultrasound and machine learning or AI models, so there's about 350 FDA-approved devices that use AI right now in general, overall, and cardiology, for medical purposes, and cardiology and radiology are by far the biggest contenders. So they own about 50% of all of the FDA-approved models now, but of the 50% is other, so it's a mix of ortho, neonatology, dermatology, things like this. There's a whole mix of others in that other category, but in terms of the medical imaging devices, only about 15 devices have any sort of ultrasound indication at all, and only about 9 of them have any sort of acute care implications for ultrasound imaging. So the 9 that are approved right now are listed here, and so you can see they still kind of fall into a cardiac theme. There's a lot of bladder scanners. Bladder scanning is useful. It's one of the earlier uses of AI in medical imaging, and so a lot of EF calculations. There's some image acquisition devices that can help with learning and image acquisition, and then there's some multi-purpose ones that are honestly mostly cardiac as well, but they help with kind of a various set of problems. But regardless, this is 4% of all FDA-approved medical devices for AI is involving POCUS and involving acute care imaging in any sort of sense. So the door is wide open. There's a lot of space here to get involved and to try to expand that arena. If you want to think about how you actually develop a tool, this is a really basic framework. So this is kind of what I teach people in terms of these are the steps, and as you will be able to see, it involves a hugely diverse team. So our team consists of clinicians like us, ultrasound teams, data scientists, machine learning experts. We have a lot of device people as well to actually implement anything that we make, and so it's a widely varied team. We have a very big group of people working on this. But first step is to generate the data sets, and that's not as trivial as you might think. It takes a long time to get data sets big enough to actually train these models. So that is literally just going in and scanning and getting ultrasound clips, for example. You can retrospectively hold them too, but that's a very important step because your output is only going to be as good as your input. So anything that you put into it is going to directly affect how good your model is, how accurate your model is, backend. So that data set generating stuff is super crucial. You do have to annotate some images. So you want to be able to put in data that has some gold standard answers so that the algorithm can kind of learn what it's looking for. You don't always have to do this, but it's helpful. And generally, we say about 20% of images need to be annotated, which is a really laborious task for experts, right? So we literally will sit there on our iPads for days, weeks, just sitting there going through marking things that we're interested in. There are definitely better ways to do this, which we can talk about later, but that's the basic way that you do that. So for example, on this one here, we've marked all the B-lines. B-lines are a pain to mark, especially on stills. If you're going through and you're marking all the B-lines, it's a laborious task. So those two sets are kind of the clinician input piece. And then after that, we pass off our annotated data and our unannotated data to our data scientists. And so they're the ones who will run it through that model development piece that we saw a few slides back. And that takes, generally for us, a couple of weeks to run and to get any sort of output whatsoever. And then based on how accurate our output is, we can either have to run it again, use more training data. So it's a circular process in step 3. And then, once you have a model, you have to deploy it, right? You actually have to use it in the clinic. And this is actually a really hard step too, because, are you going to use something that's hardware agnostic, right? Like, was this model developed only off of minor machines, for example? Because that's maybe not going to be as accurate for like Philips machines. Are you going to use Wi-Fi to deploy this, or is this something that's going to live inside the software of the machine, right? Because like in a lot of settings where these would be helpful, they may not have like continuous connection, right? And so you need to really think about all these pieces. And oftentimes people will get to this step and realize they didn't consider something, and then you kind of have to go back to the beginning and start all over again. So thinking about the whole process like longitudinally is very helpful from the beginning. And so this is kind of the workflow that we use whenever we're generating our models. So why ultrasound in AI? So this is kind of the workflow I think of, or the uses of ultrasound that I think of that can be amenable to artificial intelligence. So you want to acquire the image, right, which is not trivial. You have to train people manually to do that in the past. You have to interpret the image, also not as easy as people make it seem, right? And then you actually have to use that image to make a clinical decision, right? So each of these steps has pitfalls, and you can actually use machine learning to kind of optimize any of these given steps for a new learner or for a group of people that maybe are less confident in their skills, or they just don't have training, or even experts that are just not sure, and it's a tough clinical problem. And so, ultrasound, many of you have probably thought about this, but there's diverse utility in ultrasound. It's portable, it's easy to use. I'm sure many of us know colleagues who don't have ultrasound training but have bought, handheld devices, and they really are excited to use them, but they just don't have the training to do so. And so there is definitely opportunity to deploy these tools. The issue is we just have to build them. The other reason that it's actually pretty helpful is the binary outputs, like I said. So the classification training is a lot easier than the segmentation. And so if you're looking for, an exact auto EF calculation, like you want, a precise number, that's a little harder than saying, high, low, extremely low. And so you can kind of break it down into questions like that. So the goals when we're developing models, so we think about all those steps that I talked about in the last slide, but you can also use it in processes like QA and education. So it doesn't just have to be image acquisition or interpretation. So QA and education can benefit from machine learning models to optimize any process that is automated and repeated multiple times. And then therapies and procedural guidance, right? So, identifying anatomy and structures is actually kind of challenging, especially things like nerve blocks, right? It can be hard to see a nerve if you're not used to it. And so anatomy identification is another area. But generally speaking, a lot of people focus on kind of this diagnostics piece, which is the big one for new learners. And so, automating image interpretation, reducing time to diagnosis would be a good goal, right? Like if you have to wait for a radiology scan, because you can't interpret your own image, that would definitely improve time to diagnosis, potentially decrease length of stay. There's definitely a lot of patient-oriented benefits that you could have from applying these models. And then in terms of QA and education, optimizing workflows and streamlining training could actually be useful as well, right? So if you have algorithms that can automatically help guide your hand to acquire a better image than what you have, that's real-time live feedback where you don't have to have an expert there with you in real time, but you still are getting the benefit of, learning hand motions, learning how to acquire images. And there's I think 2 or 3 devices that actually can do that right now in the market. So it is possible. want to pass it off to Dr. Goldsmith to talk about some of the financial implications.
Thanks, Dr. Duggan. I think I have the most interesting component of this because I get to talk about the money. And my hope is that by the end of my small component, that everyone here will understand why so many companies are jumping into this field, and then maybe generate a discussion on the ramifications of that and how that will affect us in our daily practice. So I think we need to look at three main components, and there's probably some more here, but these three are very easy to understand. So think about education, interpretation, and acquisition. So your input is the education you provide to your co-physicians, your APPs, your residents, and then that output is then they are going to generate more ultrasound scans, which actually generate more financial revenue for your department. Pretty simple. However, that education comes at a cost, and that cost is your time. And I think we all undervalue that time because we do it so much that it becomes second nature. I mean, ultrasound of all the divisions in EM probably does the most education that you can think of. And that education consists of all the time you spend in curating your didactics, and then eventually going to the department, finding the pathology, finding that interesting scan for your residents or APPs or whoever it may be to get the scans that they need. So what does that look like right now, and where is the future of this education going to come from, and what it'll look like? So currently, our time is the most valued time, right? We put so much time into creating those lectures, spending that one-on-one time, but you also need a large infrastructure. You need a patient volume to generate those scans with the associated pathology, and you also have to sit there, find that pathology in the department in those limited time frames of your scan shifts. Then, after said and done, you still have to recertify attendings over and over. Now, the future. So instead of our time being as valuable, our time is valuable initially to generate those expert annotations that Dr. Duggan was talking about, but it's really about product development, and that cost is really involved there. It takes a long timeline, but when it's there, the scalability is huge. But that lowers the infrastructure need as well as the pathology need, as you'll only need a few pathological scans to get people very comfortable with finding that image. So I kind of want to give it a broad example, and I chose this paper because it'll make sense based on a Caption Health paper in the future. But this is a Romolo paper, and it looks at learning curves. And basically, he looked at the modalities of all these modalities of point-of-care ultrasound and how many scans it takes before you get a great agreement percentage. But I want to focus on one specifically, and that's cardiac, because it's fairly easy to understand. So what their group said was that about 30 point-of-care ultrasounds in cardiac got to about a 90% agreement. And remember that number later when we talk about the Caption Health AI. But to do the math, and we don't have to go into all the details, but if the physician had an average rate of $300 per hour, you spent some time on didactics, you spent some time scanning, maybe you only did 10 of their 30 scans, and the trainee was also an attending, you take those costs for the lecture, you take the cost of your supervised scan, all of a sudden you're looking at $4,100 just for cardiac alone. And that's for one person. And yes, you can apply some economies of scale and say 2 people, but every modality is different, and we do so many modalities that this adds up to considerable to, I would say, $20 to $30 just for individual. It's not sustainable, right? There's only so many of us in this room, so many in this conference, and so many in other departments that you can't train everybody. And this is the reason why AI exists. It's that scalability. So let's kind of flip that page a little bit and think about it from the AI side. And this study just came out in the past year, and basically it's a study that examined a group of novice nurses. They gave them the Caption Health device, and that Caption Health device basically can help you acquire. It can also help you interpret, right? So what they did was super interesting. They gave them an hour on how to understand how to use the device, and then they put them in the echo lab. While the echo tech also did their scan, they did their scan. And so you had 2 things to compare. And the main table here is that basically through the Caption Health device and minimal effort, their number of scans with sufficient quality was in the high 90s to mid 90s for LV size, LV function, RV size, and pericardial fusion. Everything we care about on a point of care basis. And that's just adequate view. And if you turn around and look at Romolo's study from a learning curve, it took 30 scans and a lot more time that went in there just to get to about a 90% agreement. And that agreement was looking at experts reviewing those scans as well. So again, the question is AI even better than what we can get our own trainees for, right, at a smaller cost, except for the development cost? So let's take a step backwards, and let's look at the acquisition and interpretation side. Right now, the medical provider has to provide both the acquisition and the interpretation that goes into your ultrasound image to bill for it. You have to document it, which means you have to say why, you have to provide an interpretation, and save your image. And that basically provides a global payment, and depending on where you are in the hospital, like EM, you get both a professional payment and a technical payment, which goes to your equipment. Inpatient, it's only your professional payment. So differences on both sides. However, in the future, your algorithm is going to assist both on acquisition and provide that interpretation. So if I acquire, but the model interprets, should I get paid less? What if a third party acquires the image and then you interpret, or the machine interprets? Should we get paid less at that point? So think of those ramifications. A lot of our buy down that exists right now is based on that revenue that's generated in the department through ultrasound. Would that go away? There's one good example. So for bladder scans, right? AI has kind of taken that over and provided an automatic number for them on the floor. However, in the department, probably most of you guys do the same. We use our ultrasound devices. We generate the higher CPT code. So there's two main CPT codes for this. One is like we're all used to. You have to state why you're going to do the scan, tell your findings, save the image. Now, in your bladder scans, that's not possible, right? It just spits out a number. There's no saving the images, no nothing. So what happens is, for the one that we're used to, it creates one CPT code that has a global fee. So you get both the professional and the technical fee. With the other one, you actually only get the technical fee, and even then, it depends on where you are. Because if you're in the inpatient setting, you can't generate a technical fee if your whole cost is bundled, right? And that's why all technical fees go away if they get admitted to the hospital. It's just a professional fee. So the question is that going to change the future of how we think? So think about it. Your return on investment. Current practice, you got to find the pathology, you need the infrastructure, and you really need that expert time. However, in the future, you have to have the purchase cost, the product R&D, but from our perspective, are we going to actually generate less revenue associated with it? The question, I am not really sure. But what I do know is we're kind of hurting ourselves, right? There's not enough of us to train all of the people that are interested in point-of-care ultrasound, and that's why that scalability is being shifted to the right, right? So I'll leave it up to Dr. Fischetti to kind of explain what's going to be going on in the future.
Thanks, guys. So if we haven't convinced you yet about AI and its implications and everything else that'll follow, we'll get a little bit more into it. So, as Dr. Duggan explained, just about the nuts and bolts of AI, and Dr. Goldsmith has explained kind of like the financial implications and opportunities within that. I think the next questions the other questions that often come up and that we often get too is, okay, well, I'm convinced about this. How do I get more involved? Or, it seems like there are opportunities, but I don't even know where to start in that. And so, in the next few minutes, we'll kind of go over steps in project development, and then strategies for academic industry collaboration specifically, the opportunities within those, and then the ethics and other considerations within that. So whenever you talk about opportunities within AI and opportunities with industry, I like to think about AI in three big buckets. So, as we mentioned, there's the data bucket of AI, right? All of the data that you're going to be gathering, organizing, cleaning, and analyzing. You have the model bucket of AI. So once you have the data, you're creating the models from that, and that involves the training, the testing, and the validating of the models. And then you have the hardware, software, and personnel component, which is like the actual machinery upkeep. Maybe your AWS or your cloud storage, and then all the statisticians, computer scientists, et cetera, who are going to be involved in that. And so where do we fit in as the physicians and the clinicians involved in this? I want to hone in a little bit on the life cycle of AI in terms of going from the creation, validation, processing, regulation, and final integration of it. And I think where we fall as the physicians, clinicians, is more in the creation validation side. And that's where I think our sweet spot is probably for anyone interested or potentially interested in industry or research opportunities. And Dr. Duggan touched on this, but really I think the take-home point is that AI models are really limited by the data on which they're based. So bad data in means bad models out. And so what that really means is that it comes down to quality, so quality data. And a lot of the time and effort that you'll put into really good models is the cleaning, the curating of it. And there are other companies that do that and facilitate that, and we'll kind of talk and bleed into what that'll mean, as academic missions moving forward. But that leads us to the next few speaking points, which is obviously there are private industry opportunities within there. So you could go work, as a CMO of a private company, and maybe like you're the physician expert for that company, and you're staying within that private industry model. Or, maybe you just work full time at an academic center and your interest in your research is just in creating the models or, curating the data sets for whatever interest that you have. But I want to speak a little bit more to the private-demic model. Recently, I was at a conference, and it was a very academic conference between Mass General Brigham and MIT, and I felt like the glaring issue that we didn't talk about is how opportunistic it is to have this private-demic model, meaning the fusion of both industry and academics together. And I think that's really where the momentum should be going towards, because we can really optimize both benefits from the private industry and academic side. And so what I want to do is kind of convince you of what that looks like and why. You guys are intelligent people, so it's probably pretty intuitive, but there are a lot of pros to the private-demic model. Time being one of them. Us as researchers and clinicians, time for us comes either in actual time or more often money. So a lot of us are spending time writing grants and things like that. But if you find the right industry partner, it could be that they are supporting, your time, or maybe your buy down, et cetera, or financially paying you to some extent to do the research that you want to do anyway. And then from the industry side, they're really excited about it, because it could be that you have now given them access to either data sets or populations or opportunities that they otherwise would be a little bit more limited in finding or curating, et cetera. So the finances bundle into that. So I think thinking broadly about where this private-demic model really hits home is from both the time and the finance standpoint. And then the fact that there might be a lot of efficiency and shared mutual interests. Like, why work in silos when you can be working together on the same issue and the same problem? And so I think from the industry standpoint, let's say that you have, specific to ultrasound, a question about making your ejection fraction models a little bit more optimized, and company X is doing that already, and you have the population, you also have maybe existing data sets to do that. Why not work together and collaborate on that, and maybe fund your time and propel their industry interest forward as well? There are obvious ramifications, though, of the private-demic model, ethics being one of them. And so I think it's really important that if you're going to engage in that relationship, to really think about the implications of, what happens if we do create a model from this data set. One, who owns the data? Two, who's liable for that data? And three, what does it mean if something goes wrong with the model? Who's responsible for that? And then who's also responsible for the retraining? Knowing that the potential for overfitting the data, or not the model not being generalizable enough is an actual reality. Who's going to be responsible for retraining that and recollecting the data or fixing the model? So all of that should really be kind of well thought and smoothed over before engaging. And so that's going to involve a lot of legal and a lot of admin from your academic side, and then also from the industry side. And so I think similar to any grant that you're going to write with the NIH, time will definitely be invested in it. But if the layout and that infrastructure is in place, who's to say that you do this with company X, that in 4 years, the same opportunity comes up with company Y, and now your infrastructure is in place. So it could be worth the effort to really put in that infrastructure to facilitate this private-demic model. So I think the other topic that often comes up, at least for us, and again, us being what we consider the experts in point-of-care ultrasound AI, is that a lot of colleagues and friends will come up and say, where do you find these opportunities? How are you getting the companies to come to you, or where do I find those opportunities? So some of the things that we always recommend is, look at your pain points. What are the pain points maybe in your workflow? So For example, maybe your ESI triage system is off and you feel like there's a bias in like who gets triaged to an ESI 4 versus an ESI 1. That's a pain point in your workflow. Maybe it's, okay, we collect 500 scans of ultrasound imaging and we need to be responsible for auditing those and reviewing those every week, but it's impossible with the time allocated to me. Like maybe there's a quicker way to come up with, an AI model to triage that system or to look at vital sign changes before a patient codes. So considering a pain point might be a really good starting point for you to either, find the right industry partner for a project or, create your own project from that. I think whenever people think about AI too, they always think about this like data gold rush now that's happening. People have been sitting on a lot of data for a while, and now people are like, oh wow, this is probably very valuable. I have 10,000 chest x-rays, or I have like thousands of ultrasound images because I'm a fellowship director and I've been collecting these for years. And so maybe that's you. Maybe you have thousands of ultrasound images and you're like, I just don't know what question to ask, or I don't know, what to do with it. I'm not a data scientist. You don't have to know every part of the process to just know, where to start. And so part of it could be is that, maybe you're the lung ultrasound expert and you have thousands of pleural line images. That could be your first starting point and your first question. And maybe you just find the right industry sponsor to kind of move you forward in the right direction for your research and for your AI models with whatever question that is. The other opportunity often comes from networking. So being at a conference like this, you have existing vendors and sponsors at this conference. Sometimes it's just being in the right place at the right time. You have your own research interests and maybe you meet someone from another company like Philips or GE or whatever, and they're working on the same issue. Partnering up with people with similar interests and utilizing these conferences just for that, for networking, can often be a really good opportunity to find the right next routes for industry-sponsored grants or, consulting projects, et cetera. Grants and other sources. So let's say you do have a project or you found the right industry sponsor that you want to partner with. The NIH has really, really great opportunities. If some of you, I'm sure, know about it, but SBIR and STTR are really good opportunities for academic and industry models to get non-dilutional grant funding. They're just as prestigious, obviously, as any other NIH grant. And then there's others like state to state that really can be good opportunities to help you fund. Obviously a rigorous amount of work involved. SAEM has the EMF grants as well. So those are really good opportunities to fund your interests as well. And then startups, and that's what we'll speak to next. But seed stage startups and even Series A companies, and maybe they're beyond, but I feel like those those younger companies really serve as really good opportunities to maybe get into a situation where, let's say you have these x-rays or these ultrasound images that you've been sitting on, but, it's going to take too much time for you to clean the data. Maybe there's a company out there that does it, and maybe they'll do it for cheap for you because you're the academic partner and you offer them the data. And in return, they'll clean it for you and kind of demo with it. But the setbacks being, maybe it's a startup, so it'll take longer than you expected, but it's for free. So kind of being eyes wide open into situations like that and being creative for other avenues that maybe you can outsource your own work for. And so specifically for us and for our group, like using Brigham as a case study. So I actually met my team because I was working full-time at Centaur Labs as a CMO, and through a mutual contact, we met. I met Andrew Goldsmith, and we just started talking about shared mutual interests from our standpoint as a company, and then also from his standpoint as an ultrasound division. And it turned out this all happened in the middle of the pandemic, that there was an NIH grant that was supporting COVID-funded research specifically for B-lines and for at-home care. And so what we had decided on was to do like a little pilot study and a supplement basically to an existing NIH grant. And so that was our first kind of introduction to this like private-demic model of working together, our company and this this institution. And then it just evolved. And so eventually, fast forward, we applied for a Massachusetts Life Sciences grant, and we were awarded $750,000 to create one of the largest, as far as we're aware, open access public data sets. over 3 years. So what that means is that the state of Massachusetts awarded part of the money to Centaur and part of the money to Brigham for us to populate an open access data set that other researchers can use. If you guys know the MIMIC data set, Beth Israel did this several years ago with EKG data and a lot of cardiac data. But basically what will happen is now this is accessible to anybody with the appropriate credentials who has gone through the amount of other credentialing to access the data and use that for their own research. So there are existing grants and opportunities for you as a researcher. Sometimes it's just knowing where to find them and what industry partner to partner with for that. And this has been a really symbiotic relationship for us. And then an opportunity as researchers to get publications out of it too. So just future considerations and things to keep in mind. We briefly touched on the ethics of it, but the data sources themselves, like I think outlining who's going to be the owner of that data, is that going to be the academic hospital site or is that going to be the industry partner involved? There have been a lot of case studies over the year between Google and Amazon, et cetera, where they've partnered with hospital systems, and that's been a big issue and an ethical concern for patients and for clinicians and for the hospital systems themselves. So who owns the data? The financial remuneration involved in that as well. It's hard because right now, and I'll show you a paper after, but there's a paper published in 2020 that basically said it's allowable for anybody with data to basically, you can charge for data, you can clean the data, and you can pay for the data curation, but the actual data itself should not be purchased unless there is an agreed upon contract between the patient that they are actually like selling their data. So, for example, a patient comes in to Brigham and Women's Hospital, they know it's a teaching hospital. When they get registered, they'll sign away, patient rights that this is a teaching hospital, that they may be involved in research if approached, et cetera. But even still, we're collecting data all the time in the hospital system. It's hard. Brigham, every hospital at this point is kind of sitting on a bunch of data, and the question keeps coming up, well, who's actually responsible for, retaining the rights to those data? Like, do the patients get compensated for the data that they generated? Is it the clinicians do because they collected it? Is it the hospital because they keep it and they maintain the privacy of it? That's been a really hard sticking point, but again, I think in general, the idea from the 2020 paper that came out is that it's okay to charge for services that is involved in the cleaning and almost the admin of it, but the data itself should be considered a public good. And that also comes up with the liability too. So when you're creating these models, and let's just say they're not as generalizable or they're off the mark in another way, the liability, does that come down on the company that created the model or the hospital that created the model, or is it on those patients that contributed to it? It's all still being actively kind of developed and evolved as we're speaking, but the consensus within the community is that data should be a public good. And we talked about this a little bit, but this is the paper that I had mentioned. So this is one that we often reference, though, and this is the 2020 publication that, if you're interested, it's a long read, but it's a really good paper that really kind of outlines how to consider the data sets that you generate moving forward and how to use them and how to optimize them and who to consider responsible for that data. And so if you have any questions, feel free to reach out to us. You can tweet at us or email us. A lot of this has been trial by fire. I mean, sometimes the opportunities just present themselves and you just happen to be in the right place at the right time. And then you kind of just ask for forgiveness, not permission, when you're creating grant opportunities or research publications or papers. And maybe that's the best way moving forward, as everyone's kind of just figuring out the ethics of this all and what the financial implications really mean down the line. I don't know that anybody truly has all the answers yet. So, yeah, thanks.
Whenever we give this talk, either like in our institution or other local areas, people get really fired up. And there's lots of questions, particularly regarding the finances and the ethics of it. So we wanted to give some opportunities to questions or kind of have a discussion about any parts of this that are particularly contentious or that you have questions about, just because we always, these conversations always devolve into many, many, many hours with our team. So anybody have any thoughts about like the financial implications or the ethics or the kind of private-demics model, anything like that?
Did anyone get any industry opportunities from this conference?
I'll ask a question. My name's Joe Perry, I'm Brown. The question I have for you is, so a lot of the data is what the models are built off of, right? And really the value is where the data is, because you can generate visual models from improvements. So do you feel like it's appropriate, for industry or whatnot, to then license the model that you've developed off that data? Or do you think that, it's really that these, industry companies are going to be wanting your original data to then go back and continue to refine the models and tweak them?
That's hard, and that's something that's honestly institution to institution, even department to department specific. Mass General actually has a really, really good and robust system that already exists with radiology there and some other industry sponsors, which will probably be different than what we generate and what we kind of have going on at Brigham within our ultrasound division. So it's hard to just do a catch-all to that question, because it will probably be institution dependent. There are certain places that are a lot more forgiving and creative than others. But licensing is certainly a route around, who owns the model. And licensing is probably the most logical one.
Yeah, it's interesting because, there's a gold standard now at MGB about how this works, because CT scans and MRI images have already been established, and there has been private industry funding that research, right? Now, collecting that data, annotating it, and then that licensing of that model was split between the two institutions, but the private institution had the right to buy out that other 50% at a certain cost that was agreed upon before it started. And so I wonder if that will be somewhere around the line, but don't forget that private institution money drove that model generation, and they're the ones with the majority of the risk associated with it.
So what I see happening is, I think it's great you're going to create an open access data platform, but then people from, across the world, and it is probably it is in the best interest of the patient to create the best forming models, but people are going to use that as an opportunity, I'm sure, as a business model to then launch off of. And how are you guys going to address that?
So Mimic, the Beth Israel set, I don't know if you guys have used it or worked with it. Mimic has a really good model, and that'll be similar to what we do too. But you basically have to prove that you did, all your IRB training. 1, that you're not a computer, but 2, that you did the IRB training, and 3, that you show your credentials and your intentions for it. And so while it's open access, it still has very strict regulations for how you use the data and what it's for. But yeah, in theory, could people lie on it? Yes, it's just a code of honor, in using it. But at the end of the day, if a company's going to go out and use this data and create a model that's superior to anything else out there and that helps patient care, that's the whole point.
I think you always have to circle back into what's best for patient care.
Yeah.
And if you think of that at the forefront of your brain, everything just makes a little bit more sense at that point.
And I think we're all motivated differently, right? Why do we work in academics? We get paid almost nothing to work 3 times as hard, but we still stay in it, right? And so at the end of the day, we all kind of just find ourselves in the right spot, and we're all motivated, I think, for common good. So
The problem with that model, though, is that it's going to be a private company that's going to gain off of that, and it's not going to go back into the institution or patient care,
potentially, but the issue that's coming up now is that, okay, yeah, you see these companies coming out with their models, but how do they validate it? Somebody needs to validate it, right? And so somebody needs to do the research and the work. And so then, even if they make these models, they realize they still need us, and they need the stamp of approval. So
Caption Health study is very unique in that, right? It's the first validation of an AI algorithm, basically. There's no other paper around that shows a validation of AI algorithms in clinical care. And I wonder if that's in the future and how it goes into the workflow. And that's where we'll come back into the flow again, where we can generate grants and have funding through that way.
the other reality too is when you're talking about deep learning models, you're talking about hundreds of thousands, millions of data points, and your training set may just be, 2,000 images, et cetera. Images, not clips, because you have thousands of images even within that one clip. And I mean, it's a lot of time involved, but it's also not a lot of data. 3,000 images is really not a lot, and it's specific to, let's just say, Massachusetts. Is that generalizable to California? Is it generalizable to Nevada? And so there is we talk about bias all the time in data science and being stewards of that and making sure that the models are not over or under fit. So the validation part is going to be critical in any FDA approval process moving forward and has been.
Caption got emergency FDA approval. That's how they got it
And
quickly.
yeah, Caption did get emergency, but they also have been almost like a standard of care because nothing previously has existed within that. And the FDA is still actively figuring that out. Like if you call any of their representatives, they'll say, we're figuring this out real time. There is no structure. And so, if you even notice that paper that came out about ethics, that was only in 2020. Like this is all very, very new. And it's actually a very exciting time to be in this field because we're going to be the ones creating the rules and the boundaries.
Any other questions? Awesome. Thank you guys. We appreciate it.